Hello everyone. My name is Daiichi, and I will give you the lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is environmental contamination caused by the accident of Fukushima Daiichi nuclear power plant, Volume 2. Are you ready?
Mr. Daiichi, last time we talked about how the environmental contamination expanded after the accident of Fukushima Daiichi nuclear power plant, and how the air dose rate decreased with time.
Correct. And I promised that this time I will explain the reasons in detail why such phenomenon happened.
That's right. My first question is, Mr. Daiichi, why does air dose rate decrease with time? And another question which I would like to ask you is, why does the decrease rate of air dose rate slow down with time?
Yes, you remind me of the important points. Let me start with the reason why the air dose rate decreases with time. I would like to introduce you here main three reasons, although there are some others. That is, disintegration of atom core, decontamination, and influence caused by meteorological reasons, such as wind or rain. I explain in another lecture, but radioactive materials emit radiation through disintegration of atom core, and they convert into stable isotopes, which don't emit radiation. And characteristically, each radionuclide has its own particular time, by which the number of radionuclide reduces by half.
What is the particular time specific to each radionuclide?
Okay, let me use previous animation to explain it. If the duration of time, during which the number of radionuclides decreases from 8 to 4, is defined as T. The duration of time, during which the number decreases from 4 to 2, is T, and the duration of time, during which the number decreases from 2 to 1, is also T.
8 decreases into 4, 4 into 2, and 2 into 1. Okay, I got it. Therefore, the number of radioactive materials decreases with time, and the decrease rate also slows down with time.
That's right. In fact, in the case of Fukushima accident, a variety of radionuclides were released into environment, so the number of radionuclide would not decrease so simply like this. But this animation describes the basic concept of physical phenomena. By the way, this time T is called half-life, or physical half-life, in order to distinguish with other kinds of half-life. Each radionuclide has its own physical half-life. The next factor is decontamination. It is explained in another lecture, but the radioactive materials are removed by the decontamination. So, decontamination activities contribute to the reduction of air dose rate, although it is limited to locally, when looking from viewpoint of wide range of area.
Yes, I remember the effect of decontamination.
The last factor is wind, rain, and other meteorological phenomena.
Mr. Daiichi, how do wind and rain pertain to the reduction of air dose rate?
Okay, that is a point. Especially shortly after the accident, radioactive materials deposited onto the ground were likely to be affected by wind or rain, compare with present time. Wind, rain and other meteorological phenomena transferred the radioactive materials, and that contributed to the decrease of air dose rate. Of course, this migration of radioactive materials increased the air dose rate, in some part of places, but especially shortly after the accident. As a whole, such phenomena seem to contribute to the decrease of air dose rate. By the way, this effect that the air dose rate decreases by wind, rain or other meteorological phenomena is called weathering effect. Please keep this phrase in your mind, taking this opportunity. This weathering exerts its effect shortly after the accident, when the radioactive materials are likely to be affected by wind or rain. For some radioactive materials, its effect diminishes with time, because some radioactive materials have characteristic that they're firmly adsorbed to soil particles and become not easily to migrate. So, let me wrap up my lecture by providing you the key points. Today I explained the reasons why the air dose rate decreased as a whole with time, after the accident of the Fukushima Daiichi nuclear power plant. There were three main reasons for this. That is, disintegration of atom core, decontamination, an effect caused by meteorological phenomena, like wind and rain. And I also explained the reasons why the decrease rate slowed down with time. First, the concept of physical half-life was covered. If the number of radioactive materials becomes less, the decrease rate also becomes slow. And some radioactive materials become unlikely to be affected by wind or rain with time, because they are firmly adsorbed to soil particles. Okay, today's lecture is now dismissed. See you next time. In this channel, the useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.